Hi team. You've been doing a great job of battling some of the hardware issues that have very clearly become apparent in using some of the software that I've written for you. And so I want to congratulate you for pushing through some of that to try to understand the way this works. What I want to do in this video is show you, by example, another way that you can think through some of the difficulties in this challenge. The challenge with a task like this is I don't want to give away a solution, I don't want to give an answer, but I do want you to be more successful than you've been up to this point. So I think what I'm showing you here will nudge you in that direction. What you see in front of you is the field, and I've set it up in a very specific way so that I can demonstrate some other ways to implement control systems using the libraries that I've written for you on the Sphero. So I've split this into three pieces. What I'm first going to do is I'm going to drive to this position on the field using one of the functions that's built into the Sphero library that I built. There's this handy RVR drive to position function which lets you drive to a set of coordinates. And I'm not going to be using the ultrasonic sensor here. I'm just going to use the coordinates of this first point. Then I'm going to drive in this direction. I'm going to drive at a heading of 90 degrees, and I'm going to use a proportional control system to get to exactly this location. And the reason I know that this might be a good way to do this is in the API, I can see that there's this function RVR drive.drive, which you can give it a speed and you can give it a heading. And the RVR will drive in that heading at whatever speed you get it. So what I would like to do there is drive in the direction of 90 degrees until I get to this X coordinate on the field. And then I'm going to just use a regular drive command, similar to the examples I've already given you. And I'm just going to drive in this direction here. And I'll use a proportional control algorithm so that I just nudge that green cube. And I can see that its Y position is 0. I know that because the starting position of the RVR is the point 0, 0. So wherever you power on the robot to start, that is the point 0, 0. I've also put in some other code so that there are three distinct segments of my program. So you can see I have drive to coordinates, and I'm giving an elapsed time of 3 seconds for this movement to happen. And so my code isn't here. My code is going to go in this space. But this is going to run this while loop for 3 seconds while this occurs. And that means that this isn't going to loop forever. It's going to loop for 3 seconds, and then it's going to try to do this next step. So it's very possible that I need to change the amount of time that each of these 3 sections are running. We'll deal with that once we get to that point. The first thing I need to do is use the drive to coordinates function to get to the point that I'm trying to arrive at. And if I look at this, the coordinates that I want to use are, I'm going up 1 tile, 2 tiles, 3 tiles. Each of these tiles has a length per side of 60 centimeters. So I want to go a distance of 1.2 in the Y direction, and I'm not going to go anywhere in the X direction. So my coordinates are going to be 0, 1.2. And the command I'm going to use is going to come right out of the API. So now I'm using the command, drive to position. This angle is the angle that I want to end the move at. So I want to end this move at 90 degrees. And I want to go to the coordinates 0, 1.2 with a speed of 0.4. Let's download the code. Now, it's very possible that you caught this mistake, and this is something I should have caught myself, but I didn't do my math right. I said that we were going to go 3 tiles, 60 centimeters each one, 3 times 0.6 is going to be 1.8. The robot did exactly what I told it to do. It went 2 tiles, but I needed to go 3. So I need to change the coordinates to 1.8 here in the drive to position function. Okay, not bad. So now it's in the position I want it to be in, and I know my robot is here on the field. Now I'm going to do the second portion of my movement, which is creating a proportional control algorithm that uses the speed and adjusts the speed as the robot gets closer and closer to this x coordinate. And I can see, this time I'll do this right, the x coordinate I want to use is 1.8 meters, because this point here is the point 1.8, x coordinate, 1.8, y coordinate. And so I go back to my API and I can see that I want to give it a speed, and that speed is going to be an output that changes as it gets closer and closer to that location. And the heading is going to be 90 because I'm going east, I'm going to the right. So in my code, I'm going to put in the last line of my algorithm, which is rvr.drive. I'm going to use a variable called output, and I'm going to say the heading is 90 degrees. Here, I'm going to set my set point. My set point is the value that I want my x coordinate to be equal to, and I want that x coordinate to be 1.8. I'm going to get the current x coordinate of the RVR by using another function from the API. Function rvrdrive.getX gets me the x coordinate of the RVR in meters relative to the origin, which is the starting point. And as with any proportional algorithm, I'm going to calculate an error, and I'm going to calculate an output speed based on the size of that error, proportional to that error. And you can see that that output is the same as the variable that I'm using down here in the drive command. There is one thing that's generally a good idea to do, and that is to make sure that the value you are putting into the drive function doesn't exceed the maximum value. And so I can see that the speed is 0 to 255. So I'm going to make sure that if my output is greater than 255, I cap the value at 255. And I decided that actually instead of using 255, I don't want this going top speed because this thing actually goes really fast when it's at full speed. So I'm going to cap that output at 100. It's going to drive until, ideally, the current x coordinate approaches the set point. And I can also do a quick calculation. I know my x coordinate right now at the start is 0. The set point is 1.8. And if I do that calculation, I'm going to get a positive error, which means my output is going to be positive. So let's save this and see how well it works. All right, now what we saw was that the robot actually drove a little bit and started the turn part much earlier than I expected. And the big thing that I think that shows me is that I need to give the first part of my program more time. So I'm going to give it more than it needs. I'm going to give it 5 seconds to actually get all the way up there. And that also suggests that maybe I need this to be, maybe it might take a little more time. So let's try 5 seconds as well for the proportional part. All right, a couple things on that. One, I think now I know I'm going to increase that time even a little more because I think it completed that command. It completed the drive to command. It had enough time. I did a calculation of the output, and I'm realizing that maybe this k is not big enough. If set point is 1.8 and x coordinate is 0, I'm taking 1.8, multiplying it by 3, and getting 5.4. That's a really small speed. So I'm going to make k instead. I'm going to make it 50, which I think will get us a better response when it gets out to the second location of the movement. Let's check it out and see if it works. so this hasn't been working. And what I realized is I needed to look at my own API and study the way to use my own software because I've forgotten. I'm embarrassed because I should know how to use my own software, but I forgot some very important things. It's right here in the API. It's something that it says it prepares the RVR to start sending location data, and it says this must be called before using any of these, and I completely forgot this. I should have read it, and I didn't. So now I am calling RVR sensor start at the very beginning. The other thing that I need to do is I need to call RVR.update sensors while I am looping so that I'm always updating with the most recent coordinate data. All right, so with that, my code still doesn't get to the location that I want it to have, and the main reason is the K isn't big enough. So I'm going to actually make this K value, I'm going to make it 150 or maybe even 250, so it's really, really going, and if it turns out that it's too much, this will limit the speed that I'm using. Let's download this to the RVR and see what it does now. So here's where things stand. I've gone through, I'm setting the X coordinate to 1.8. That is my set point. I'm leaving K equal to 50, the wrong angle. So when I have negative 90, that's going to turn it to the right. All right, everything is looking good. I'm using a K of 50. I think this is going to do it. Let's download it into the RVR and see what happens. All right, so successful. It gets pretty slow at the end, so I know what I'm going to do is I'm going to increase that K to 100. There's nothing wrong with that. If the speed gets too much, I think it's going to work out just fine. So last thing, I'm going to drive with on-off until the Y coordinate is 0. That brings me from where it currently is to this location, and hopefully, just using this, I'm going to nudge that green cube and I'll have earned some points for this challenge. So I'm not going to make the same mistakes as before. I reset my time. My new set point is 0. I'm going to use, since I'm using on-off control, I don't even need a K value in there, and so I'm going to keep this really simple. The set motors command for setting the powers to the left and right motors, and I'm just going to set that power to be a straightforward and 80. Else, okay, so I've hit 0, I'm going to do RVR dots. So there's one other thing that I didn't do, and that is I didn't actually turn the robot, the RVR, so that it was pointed down the field. And so that's a little bit of silliness. I'm going to put that in, and so I'm just going to drive at a speed of 10 for just 1 second, get it going in the south direction. All right, so I'm going to calculate the elapsed time one more time. So I'll update the sensors. I'm going to get the Y coordinate using the getY function. And if RVR.getY is greater than or equal to 0, I'm actually wondering if it's doing something unexpected. So I'm going to do if RVR.getY is less than 0. So I'm going to do that. Instead of stopping the motors, I'm going to make it go. I'm going to set both of these to be negative. All right, team. So I just tested the code a bunch of times and it wasn't working, and it was all because this pin had come out of the robot. I think I've been very real with you as I've gone through this whole process. Even with the software side, it's not 100%, consistent, and that's just normal. So here's what I've done. I have taken all of this code, I have gotten it to work as intended, and I have uploaded all of the code for the video you're about to see on the GitHub repository. So you will find it there. So this is the final example of the code that I set out to do in the very beginning of this video. And I hope you can use this to help with further solving this challenge that I've given you. Good luck. I hope this is, in the end, more enjoyable than frustrating. If that doesn't happen for you, at least you're learning a lot. Hang in there. See you next time.